Hi everyone, welcome back to Math Tutoring. Today's lesson is on parallel lines. So parallel lines are two lines that never meet. So no matter how far they are extended in either directions, they never meet, and they go in the same direction, and those are called parallel lines. So I'll show you an example. So you have two lines continuing. So you got one line and you have another line going in the exact same, okay, it should be straighter, sorry. But going like that, they have to be the exact same distance, like going exactly the same direction, same distance like throughout each part here. So in here you'll see, and what happens with these lines, what happens with these lines is they never meet. So this distance here is always going to be the same distance. So if it's x here, it's going to be x here. So all the way across forever. So there's always the same distance between them. So they're completely parallel and they never intersect each other. Okay? So a line that intersects two parallel lines is called a transversal. So I'm just going to show you that for a second. So when you have two parallel lines like this, and okay, let's try it here. So when you've got, say, when you have two parallel lines going like this, say in this direction, and then you have a line intersecting those two, say something like this, this line here is called a transversal line. Okay, so what happens is it generates 8 angles with the two parallel lines, and you can see it here. So say this line was PQ, and this intersecting these two parallel lines would generate 8 angles, 6, 7, and 8. Okay, and as you know, a straight line, the two angles, when you have a straight line and you've got a line through them, these two angles here always add up to 180 degrees in measure when you have a straight line, okay? So angle alpha and beta here, alpha plus beta would always equal 180 degrees. So over here, angle 1 and 3 added together would be 180 degrees because they, together they form a straight line. Angle 5 and 7 added together would be 180 degrees. 2 and 4 would be 180 degrees. 6 and 8 would be 180 degrees, but also 1 and 2 would add up to 180 degrees because they also form a straight line beside each other. And 3 and 4 would add up to 180 degrees. 5 and 6 would add up to 180 degrees, and 7 and 8 would add up to 180 degrees. Now when you have a transversal intersecting two parallel lines, the pattern that it makes is called the Z pattern, and that's one in mathematics, and that's used to figure out angles. It's called the Z pattern. Okay, and the pattern here, you'll see like this angle here and this angle here, these are called alternate angles. Okay, and these two angles will actually be the same measure. So according to the Z pattern, angle 3 and angle 6 are actually the same, and actually angle 4 and 5 are also the same measure. Okay, so these alpha and alpha are the same, they're equal angles. They're called alternate, but they are also equal angles. Angle 4 and 5, if you look carefully, they're both obtuse angles. They're bigger than 90 degrees, and those two are actually equal. Angle 3 and 6 are both less than 90 degrees, if you look carefully here at the angle, and those are equal. Okay, so that's according to the Z pattern. And the Z pattern can also be, you can also look at the triangle in a different way, and you can see the Z pattern in over here. You can look at it from here, and you can also create a Z like this. So going the opposite direction, that is also, there's a Z pattern there as well. And in that Z pattern, we have alternate angles here and here. So like I was saying, 4 and 5, the two obtuse angles are equal. They're both alternate angles, and they are equal to each other. Okay, so that's what I was saying before there. So you can see the Z pattern in two different ways. Now when you look at something like this, you also have what is called the F pattern. So the F pattern, you can see it right here in this situation. And according to the F pattern, we see that angle, this angle, like that's referring over here, and this one here, so this and this, angle 4 and 8 are also, they're called corresponding angles. So that's using the F pattern. I'll just write that down here. So F pattern, we have corresponding angles which are actually equal to each other. Okay, so angle 4 and angle 8 are called corresponding angles, and they are equal to each other, and that's because they are both, if you look carefully, they're both obtuse, and they're actually the exact same measure. And the F pattern we can see in many different parts here. We can see it here as well, drawing it this way, and over here we've got 3 and 7. Angle 3 and 7 are also corresponding. Angles 3 and 7 are corresponding as well. So they are also equal to each other. And if you look carefully, they're both less than 90 degrees. Okay, and the F pattern can be used in many ways. Like you can see it over... You can see the F pattern over here as well, going this way. It's there, and it's also over here as well, and going the other way. Okay, so according to that, we see that angles 2 and 6 are corresponding, so they are equal. And we also see that angles 1 and 5 are equal, corresponding. Okay, so how that works, so we look carefully then, we see that basically angles 1 and 5, angle 1 is equal to angle 5, angle 2 is equal to 6, 1 and 5, those are obtuse. Okay, actually I'm just going to go back this way because it's going to get a little bit too confusing at this point. Okay, now there's also another pattern called the Z pattern. So I'm just going to draw a new diagram over here. C pattern. So the C pattern is this type of situation here. And so that in that case you've got alpha and theta, and these are called supplementary angles. So the supplementary angles are not equal to each other. They together will add up to 180 degrees. So that all this information can be used to find, when you've got a diagram like this, you can figure out all the angles using this information. And I'm going to do some examples. But according to the C pattern, this is called the C pattern, the two angles inside. Now, as you can see, one is less than 90 degrees if you look carefully, and this one's actually greater than 90. So they're not equal to each other, and you can see that, but they do add up to 180 degrees according to the C pattern. And we can see the C pattern on the other side too, and the same thing would apply for these angles here. So if you had, another alpha and theta here, that alpha and theta, so this one would be corresponding to that. Those two would be equal, and this would be equal to this. So this one would be less than 90 degrees, this one would be greater than 90 degrees, and these two would add up to 180 degrees. Okay. So when we have this type of situation, if we have two parallel lines here, and this could be line AB, and this could be line CD, and if we had a line going through them, line EF, this is parallel. And this symbol here with the arrows shows you that you've got parallel lines, so you want to watch for that as well. That's another thing to keep in mind. So according to this, if we had all our angles, 1, 2, 3, 4, 5, 6, 7, and 8, then according to all our rules, angle 3 is equal to angle 6. Okay, so angle 3 and angle 6 are equal to each other, and that's according to the Z pattern. And then we've got angle 4 equaling to angle 5, which is according to the Z pattern again. Angle 4 also equals angle 8 according to the F pattern. Angle 4 also equals angle 8. Angle 3 also equals angle 7 according to the F pattern. Angle 6 equals angle 2 according to the F pattern, and angle 5 is equal to angle 1 again according to the F pattern. So if we look at that, and then according to, so these are the equal angles we have. So according to this, angle 3 is equal to angle 6, which is equal to angle 7 and equal to angle 2. And then we've got angle 4, which is equal to angle 5, which is equal to angle 1, 4, and angle 8. So that's how you can see which ones are angles. So 4 of them will be equal. The ones that are less than 90, and the other 4 will be equal to each other, which are greater than 90 degrees. Okay? So in this pattern, you will always have 4 angles equaling each other and the other 4 equaling each other when you have parallel lines and in a transcendental, a line intersecting them. And according to the C pattern, angle 4 plus angle 6 are equal to 180 degrees, and that's from the C pattern. So those are supplementary angles. So these here are all equal angles that we just did, and these are supplementary angles. And according to the C pattern, angle 3 plus angle 5 are also equal to 180 degrees, and that's again using the C pattern angles. So you see the C there. So using that information, you can really solve a diagram like this. You can solve all the angles. Okay. And there are other reasons why these angles are equal to each other. Like if you look at this diagram, angle 1 and angle 4 are equal to each other because they are vertically opposite angles. So angle 4 and angle 1, you can see that they're vertically opposite, so that actually makes them equal, and these two here would be equal, 2 and 3, because they're vertically opposite. So angle 2 would be angle to angle 3 for this vertically opposite reason, like using a different reason for them being equal. So if you can't remember the other rules, you can remember that if they're just vertically opposite to each other, then they are, they're equal. Over here you've got angle 5 is vertically opposite to angle 8. So that would make those two equal. And then angle 6 is vertically opposite to angle 7. So that would make those two equal. Okay? And then also angle 1 and angle 3, if you look carefully, they add up to, so this is what I was mentioning before, they add up to 180 degrees because they form a straight line. They're supplementary angles, right? They equal 180 when you add them up. So looking at that, we see that 1 and 3, 1 plus 3 is equal to 180. And then, we've got 2 and 4, which form a straight line. Angle 2 plus 4, angle 4 is equal to 180. Angle 5 and 7 add up to 180. Angle 6 and 8 add up to 180. 7 and 8, I can keep going with that, right? 7 and 8 add up to 180. 5 and 6, 3 and 4, 1 and 2. So that could keep going. So this rule here could keep going. There's more of these, okay? So given information like this, I mean, if you're given a question and you're only given some of the angles in the diagram and you're asked to measure the other ones, you can actually solve them. So say we have the following example, and you've got two parallel lines and you've got a line cutting through them, and you know that this is 38 degrees, this is W and V, and this is P and Q, and this here is R and S. You've got lines there, and this is beta, alpha, omega, theta. When you've got something like this and you are asked to say solve, you know, the unknown angles, you can actually do that using the rules that I was telling you earlier. Now I know that beta is equal to 180 minus 38 because together they form a straight line. So right off the bat I know beta is 142, and then I know alpha and beta together form 180. So if I wanted to find alpha, I would just take 180 and subtract beta, which is 142. So alpha is equal to 38, or I could have just figured out alpha because these two are vertical. It's vertical to this angle, so therefore it is 38 degrees. Okay. According to the C pattern, beta and omega would add up to 180. So if beta is 142, omega must be equal to 38 degrees. That's using the C pattern, because I know beta plus omega would equal to 180 according to the C pattern. And then over here, I know alpha and theta are equal to 180 degrees. And because I know alpha is 38 degrees from here, I know that theta is equal to 142 degrees, right? So that's the C pattern again. Alpha plus theta is equal to 180. Using the C pattern, we figured that out. Okay, so that's how you can find your unknown angles there. We do other examples. And say we have this, something like this. You got two lines going parallel. These are parallel, say. And you've got MN intersecting. And you've got A, C, and B, D. And you've got beta, alpha, omega, and you've got 107 degrees here. That's all that's given to you. So if I want to solve these ones, right here I have got, if I look carefully, it's a line intersecting and these two are parallel. Therefore I've got a C pattern here. So I know that alpha is, and alpha plus this angle should equal to 180 according to the C pattern. So that would mean, according to the C pattern here, so that would mean that alpha is equal to 73 degrees, 180 minus alpha, minus 107. So that's alpha. So we got alpha, and then we know that alpha and beta form a straight line. So that would mean that beta is equal to 180 minus 73 degrees, which would be 107. And then I know that alpha and omega also form a 180. So if I look carefully, I've got a straight line here. So alpha and this one here, so that would be alpha and are equal to 180 omega, so that would mean that omega, because alpha is 73, omega would also be 107 degrees. That's how we would solve that one. So we can do a few other examples. Like if you have something a little bit more complicated, like say you're given a triangle like this, and then you've got, say, so this is a straight line KG, and these two are equal to each other. That when you've got, so we've got two parallel lines, so these arrows represent the parallel lines. So this is line HJ and this is GF. So when you see those two arrows, you know you've got parallel lines, and this angle is given to you in the question, and you're asked to solve for, say, theta and alpha. Okay, so over here, now when you see these two lines here, that represents equal sides. So though that means these two sides are equal in mathematics. These arrows represent parallel. So these two lines here are parallel. I didn't draw them very properly there, but they should be parallel. Then you've got another line there. So looking here, we can use this, information here to solve some stuff. Okay, so looking carefully here, Now, if I look carefully, I've got two parallel lines here, and I've got a line going through them. So I do have a Z pattern here. My Z pattern is, right here. Here I've got a Z pattern going on, and that's because I've got two parallel lines and I've got a line intersecting. So according to the Z pattern, theta is actually equal to this angle right here. These two are equal according to the Z pattern, this and this. So theta is equal to 70 degrees. Okay, that's using the Z pattern. And then once I find theta, let's see here. Now, if I look carefully here at this triangle, I can see that it's an isosceles triangle because, so these two sides are equal. So this angle here, angle G, is also equal to 70 degrees because you've got an isosceles triangle. Okay, so angle G here is 70 degrees. So this is actually 70 degrees also because it's isosceles. And with that information, we know that, just trying to see here, we can use the F pattern. Going this way, so that would be, now if this here is 70, then according to rules of triangles, I know that the triangle is 180 minus, altogether is minus these two. So I know that this angle must be 180 minus 70, so that would be 40 degrees, this angle here. And I know that theta is 70, and I know that all these three add up to 180, so 180 minus 40 and minus theta, which is 70, so I'll put in 70 there, is equal to alpha. So alpha is equal to 180 minus 40 minus 70. So that would be 140 minus 70, so alpha is equal to 70 degrees. So we just found alpha, okay? So that's how you would solve that example. You can try a few more. Now say you've got something like this. You've got two triangles. These two lines are parallel. Triangle ADE and BABC. And you've got this as 45 degrees. This as 3 theta minus 8 degrees. 3 theta plus 5 degrees. And this here is just alpha, say. Okay, so now you're asked to find the measures of the angle designated by, so you're asked to solve for alpha. Okay, so to solve for alpha, I'm going to have to probably figure out theta first, so that once I have theta, I can figure out, what this all equals up to. Okay, so let's see here. Now I know that if you look at the outer triangle, angle A plus angle B plus angle C are obviously equal to 180 degrees. You've got two triangles there. So looking at the bigger triangle, looking at this triangle here, we figure this out. So that would mean that 45 degrees now one sec here. Over here we've got an F pattern going on. So if you look carefully here, we've got an F pattern right here, okay, with the two, sorry, like that, inside. We've got an F pattern going on here. according to the parallel line. So that would mean that this angle, according to the F pattern, angle B is equal to 3 theta minus 8 also, and that's using the F pattern, okay? So once you find that this 3 theta minus 8, you figure that out first according to the F pattern. Once you find that, you can start solving everything, okay? So now I can use the outside part and I can say, okay, well, 45 degrees plus 3 theta minus 8 degrees plus 3 theta plus 5 degrees are all equal to 180 for the bigger triangle, 180 degrees. And then I can just go ahead and solve for theta. So here I've got, when I add these up, I get 6 theta plus 42 degrees, so 45 minus 8 plus 5, 45, 50, yeah, is equal to 180. So I get 6 theta is equal to 138 degrees, 180 degrees. So theta, so dividing both sides of the equation by 6, I get that theta is equal to 23 degrees. So I just solved for theta. And now once I solve for theta, I can plug that into here to figure out angle C. So 3 times theta plus 5 degrees is equal to 3 times 23 degrees plus 5 degrees, which is equal to 74. So angle C is equal to 74 degrees. And according to the F pattern here, we've got an F pattern going on here as well, right here. So that would mean that because this is 74 degrees, according to the F pattern, angle alpha is also equal to 74 degrees. So we just solved that question, okay? So that's a good example there. It's just using different information to solve like different questions. You can be given another one. I mean, there's so many that you can do, but I mean, you could have something like this. You've got 2 parallel lines, and you've got P, Q, and ST, and you've got a line going through like this, and this is 68 degrees, and this is M, and maybe a line going here. That's angle M there. W, angle W, and N. Here you've got alpha, 31 degrees, beta over here, 68 degrees over there, P, Q, S, T, W, N. Okay, so find the measures of the angle designated by alpha and beta. So here's alpha and beta. So if you're asked to solve for alpha and beta, okay, so now looking here, right off the bat, I can see a Z pattern here. So the Z pattern is I would put it right here. So here, here, and here, going this way. You've got a Z pattern there. So that would mean that alpha is equal to 68 degrees. It's equal to this angle according to the Z pattern. So according to the Z pattern, we have that, and then according to the okay, so that's that part. So then we could find angle M, because we know that this plus M should be equal to 180. So angle M would be 180 minus 68 minus 31, which would give us 99, 180, so that would be 100? No. 90, 68 plus 30, so that would be 99. So 180 minus 99, 81 degrees. So that would solve this part here. That would be 81. Once I have that, I can find beta. Beta would be 180 minus 81 because beta and this angle here form a straight line. So that would be 99 degrees. So we found beta, we found alpha. Did we solve the triangle? Yes, we did. So that would be it for that one. So in a triangle, an external angle is equal to the sum of its two internal opposite angles. So this is a good rule to remember. So when you have a triangle, in a triangle, an external angle is equal to the sum of, equals the sum of its two internal opposite angles. So this B would be equal to the sum of alpha plus this angle here. So that's correct. So it would be 68 plus 31, which is 99. So beta equal to alpha plus 31. So beta would be equal to the sum of its two, 31 degrees to 99. Okay, so that rule holds there. So beta is equal to 60. Alpha, which is 68 degrees plus 31 degrees. That's another rule to keep in mind there, that external angle rule, that it equals the sum of the two opposite angles. Okay? And we can actually do another example there of that. Like if we had something like this. So if we had something like this, say, and that's not there. So 37 degrees, 143, 152 degrees, 28 degrees, 115 degrees, and 65 degrees. So this is 28 degrees. Okay, so over here, angle, external angle, so the external angle 152 degrees would be the sum of its internal angles would be 37 and 115, right? And the external angle 165 would be equal to the sum of its internal angles, which would be 37 plus 28 over here. And then the external angle 143 would be equal to the sum of its internal angles, which would be its opposite internal. So it would be 28 degrees plus 115. So that would be that one there. Okay, so that's, and there's so many other examples, like there's a lot of other examples you can try out, but you just want to use the rules to help you figure out the missing and unknown angles. So that's parallel lines and the Z pattern, F pattern, etc. So I hope you enjoyed the lesson, and if you have any questions, you can feel free to post them on the channel page. Okay, hope you enjoyed the lesson.